We're beginning chapter 3. Remember, when we start a chapter, put the chapter way up high near the top of the page in a box. Chapter 3, decimals and percents. We've already begun talking a bit about decimals in the last chapter. We changed some fractions to decimals. So now we're really going to go deeper into decimals. Last chapter was all about fractions. We're going to start with just comparing and ordering decimals today. So you should be having plenty of time to finish that. Here, as I told you yesterday, we'll go into problem of the month a little bit after you've had some work time. Okay? So comparing decimals. So the first thing I want to kind of review is what a decimal means. So who could say this number for us? There it is. There's a decimal in this number. And there's a special way you need to say numbers when there are decimals there. So who might say it for us? Okay, Ryan. Ryan.
201 and 753,000.
Awesome job. Did you hear that? If the video didn't hear, I'll repeat what he said. 201. Notice he didn't say 201. He just said 201. And there's the decimal. 753. So he said the entire number after the decimal as though it was standing alone. 753 thousandths. Naming the last place value. Very good. So when we want to know how big a number is, which digit do we look at? If we want to know really how big this number is, which side of this number are we looking at, Izzy? The last number? Does the last number tell us about really how big a number is? The 3 thousandths? Actually, it's just the opposite. It's the first number, the left side. Okay? So we see that this number, the 2 in this number, is in what place value? 2 is in the hundreds, right? So we know we're dealing with a number that's over 100. It's over 200 even, isn't it? It's a pretty big number, 200. 1. And then the smallest little digit, the furthest right digit tells us the smallest little piece of that fraction, 3 thousandths. So, interesting. When we compare numbers that are decimal numbers, we compare them left to right, which is a little different than when we add them, right? When we add numbers, we start on the right oftentimes, or most all the time. Okay? So, place value is greater on the left. So our little simple process today is really compare numbers left to right. And sometimes if the numbers are not the same length, we make numbers the same length. That can help us comparing them. So let's compare these two numbers. Very nice small numbers, 4 and 6/10, or 4 and 36 hundredths. So go ahead and jot the question down, and then let's talk about how we can compare them. Okay, so the first thing I see is these numbers are not the same length. So who can tell me how to lengthen that number 4 and 6/10? Kate? So we could say 4 and 6/10 is 4 and, how would you say that now, Kate? 4 and what? Well, if we say the entire number to the right of the decimal, it's no longer 6, it's 660, right? So 4 and 6/10 is equivalent to 4 and 60 hundredths. Isn't that interesting? And so we have 4 and 60 hundredths, and we have 4 and 36 hundredths. And just saying those numbers, probably most of you know which one's greater. Which one's greater?
4 and 6/10.
Okay, so if we were to write it as an inequality, we would say 4.6 is greater than 4.36. And that's because 4 and 60 hundredths is greater than 36 hundredths. You can even hear that, can't you? Based on what you know just about non-decimal numbers. Emily? Sure. What way would you like to do it?
Well, I always compare the first two numbers when I compare the same.
Okay, good. So that's what I'm doing here by stacking them vertically. If you wanted to, you could start on the left and say, wow, the greatest place value, which is the one's place value here, they're both 4, so neither one of them is greater. They're the same. Then we move over to the next greatest place value and compare 6 and 3, and which one's greater? The 6. So that's another method of finding which is greater. Okay? So if you make them the same length, you can actually say 4 and 60/100ths is greater than 4 and 36/100ths, or you can compare them left to right. Often that's easier to do when you stack them vertically like this, one on top of the next. And you start on the left and say, where are they different? Oh, where they're different, which one's greater? It's the 4.6 is greater. Good. Okay, Gabriel? So let's try the GP. Let me have some volunteers come up and show what you think is greater in this case. Okay. How about Olivia, number 1? And go ahead and do these at your seat. See if you can beat the person at the board to the answer and then compare it. And first of all, can you tell us those numbers, Olivia?
1 and 2 tenths and 1 and 5 tenths.
Good. And so you're saying 1 and 2 tenths is what?
Greater.
Say it again.
Is greater.
1 and 2 tenths is
Less than.
less than 1 and 5 tenths. Excellent. Good job. Number 2, Gabriel. Awesome job. And now say this little statement to us. What does it say?
64/100ths is smaller than 68.
Good. 64/100ths is less than 68/100ths. And then number 3. Okay, Kenny. This is a little tricky. This one, we have numbers that are not the same length. So let's see what you decide here. Thumbs up if you agree with her. Awesome job. And can you read it for us?
0.833 is greater than 0.83.
So 0 and 833 whats?
Oh, thousands.
Thousandths is greater than 0 and
0 and
83 hundredths, which could also be written as how many thousandths? 83 hundredths is 830 thousandths. Good. So 833 thousandths is greater than 830 thousandths if you lengthen them to the same size. Awesome job. The only other thing we need to do is try ordering numbers least to greatest. Okay? But before I do, let me back up here because Gabriel asked a really good question. What happens if you have a repeating decimal? Like, give me a repeating decimal.
3 and 33 hundredths.
3 and, let's say 3.3 repeating. What is greater, 3.3 repeating or 3.3? So go ahead and finish that. Go ahead and finish that. Do it on your paper. It's a good question. And I think a lot of you already said it. I think we did one of these at the end of the last chapter. We had a least to greatest question that had decimals and fractions both. And so let's read it together. Ready? 3 and 3 repeating is greater than. Good job. And that's because if we were to lengthen these numbers, Gabe, tell me what comes after the 3 in this number here on the left? 3. And we could continue, right? And what comes after the 3 in this number? 0. So even if you just take it out to one additional digit, you can see that 33 hundredths is greater than 30 hundredths. And you could even keep making more 3s out there, right? So good question. Okay, so go ahead and pause. Come back when you have these ordered least to greatest. Be careful because we have negatives here. So let's review. What is greater, -1 or -2?
-1.
-1 is greater than -2. It's to the right. So it's almost like it flips everything backwards in your mind, right? When you have negatives. Okay, very good. So we're going from the most negative number, it's the furthest left, -2.2, to the least negative number, -19 hundredths. Good job. And now here we have a mix of some positives, some negatives, and this is an absolute value, okay? So if it looked a little confusing to students when I just put a line, so you might make it a little longer like I did with the blue. Those are absolute value of -2 is what that says, okay? So, Spencer, come up and show us least to greatest. It's a 2. It's the absolute value of -2. -7/9. Okay, so good. She just changed the one fraction to a decimal equivalent by doing the division. Awesome. So now she has her list, and now we order least to greatest. Okay. There is no -21. You were not listening. It is the absolute value of -2. You need to listen. Okay, so she's now placed the negatives. Who agrees so far? -1. Nobody agrees? -0.7, you don't agree? Okay, well, she's just in the process, but it makes sense so far, right? What's going on? Good. Like how she's doing her accounting, she's checking things off as she goes, making sure she has everything. Okay, Ryan, you need to stop. Okay, and then what could she do? The final step? She could, yes, write them in the original form. This could be -7/9, and then the 2 could be written as -2 inside of the absolute value. So it looks exactly like the original numbers. Okay? Questions? Very nice. And here's your assignment today. Have fun.